So let's talk about the acid-base properties of salt solutions. These are commonly known as buffers. We will do examples in class. Alright, so salt solutions can be acidic or basic. And the thing to remember is that many ions react with water to form the H+, the hydronium ion, or the hydroxide ion OH-. This is called hydrolysis. And depending on whether those ions are going to react will drive the pH of the solution either acidic or basic. So what does that look like? Anions. Anions are bases. So negatively charged ions can act as bases. And what they're going to attract in the water molecule is that H+. So it's going to take that H+, bind it with itself, and that forms the hydroxide ion and increases the pH of the solution. So if we look at the reaction, if I have anions in solution with this water, there is the potential for it to set up a equilibrium where it's going to form HX, the weak acid, and the hydroxide ion. It's this hydroxide ion then that would increase the pH of the solution. Remember, you can think of water as being HOH. Okay, cations. Cations with acidic protons, like NH4 plus the ammonium ion, are going to lower the pH of the solution. If you actually would write out the equation, if I have NH4 plus the ammonium ion in water, it's going to set up that equilibrium and form ammonia and the hydronium ion. This hydronium ion is going to cause the pH to decrease of the solution. Metal cations that are hydrated in the solution are also going to lower the pH. Again, because what part of the water molecule are those positive ions going to attract? It's going to attract this hydroxide part to itself. That's going to leave this hydronium out in solution to decrease the pH or make the solution more acidic. It has to do with the attraction between the non-bonding electrons on the oxygen and the metal, which causes a shift in that electron density, pulls that OH bond, making it more polar, and the water then becomes more acidic. The greater the charge and the smaller the size of the cation will make the solution more acidic. You'll find that most often the cations that will do this are going to be beryllium, aluminum, and the iron 3. Now the book assumes that we've done some complex ion discussion, which we have not, and it might make more sense when we get there. But if you think about it, if that cation, what part of the water is it going to attract? It's going to attract with the hydroxide. It leaves that hydronium free to make the solution more acidic. So if we were to put actual, I guess, rules and words to it, I find this more confusing. I like to look at it positive, negative ions. What part of the water are they going to attract? What part of the water molecule then is free in the solution to either increase or decrease that pH? But if these words help you, by all means. All right, so an anion that is the conjugate base of a strong acid will not affect the pH. It's a really important point. What happens if I have sodium chloride in solution? I have sodium ions and I have chloride ions. Theoretically, the sodium can react with the water to set up a equilibrium with sodium hydroxide and that hydronium ion. But what do you know about sodium hydroxide? Sodium hydroxide is a strong base. It's going to fully dissociate. So this is not going to form an equilibrium. It is going to shift far to the left of this equilibrium as written, and it's really going to have no effect on the pH. We can look at the chloride ion as being the same thing. I have chloride ion in water. Theoretically, it can set up an equilibrium with hydrochloric acid and a hydroxide ion, which would make the pH increase or more basic. But what do you know about this hydrochloric? It's a strong acid. It fully ionizes. Okay, so the equilibrium is shift far to the left. I don't have any of this really in solution, so I don't have any of this. So sodium chloride actually has no effect on the pH. That was an important point. So the anion that is the conjugate base of a weak acid will increase the pH. Cation that is the conjugate acid of a weak base will decrease the pH. Cations of strong Arrhenius bases will not affect the pH. Other metal ions will cause a decrease in pH. When a solution contains both the conjugate base of a weak acid and the conjugate acid of a weak base, it's going to depend on the Ka and the Kb values of those two substances to determine what's going to happen to the pH. The one that is the weaker is the one that is going to affect the pH. And then we'll look over these examples in class, take a look at them, see if you have some thoughts on what's going to be happening, and we'll go over this in class.